Okay then, this is a new lecture continuing with what we did yesterday, which was the chapter 7. We did chapter 7 and which was about the open channel. We took the main parameters about open channel, which was T, and for example a channel T, which means the top surface width, for example. We said about hydraulic depth, which is A over T, hydraulic radius, which is A over P. We talk about the slope and the Q. That Q discharge is found by the Manning equation. We said about Manning equation, we should use it in this way, which is this one, the last version. And on energy equation also we discussed it, and we said there is no pressure. We have only the Yn plus Q squared over 19.62 area squared, for example, like that. So all these should be revised, for example. So now let's continue with another example here. We will continue with examples and see what is the new things. So what it says here, it says we have a question here, channel. An open channel with a discharge of 2.8 meter cubed per second, bed slope of 0.0018, T is 1.52. So T is given, gamma water is given, and viscosity is given. Firstly, they are asking us about B. So what we should answer B, if we look to the section, how it is given, there is no what we call it. There is no base width. There is no base width. Therefore, B is 0. So B, it is at the very deep point of the channel. We should check for a width. If there is no width, therefore it's 0, because it is sharp, and so therefore B is 0. Okay then, so we say B is 0. Then Yn, they are asking about Yn. How we can get Yn? Here it is given, the depth is given. For example, this one 0.85, it is given. But what about the rest? How much is this distance, for example? How much is it? Okay, so what we should say about this one, I would say it would be, if we check, here it is 1.52, it is given, which is T. Since T is given 1.52, I can find somehow the relation between the vertical here, this vertical, to the horizontal. We know there is a relation, because here it says we have one vertical gives us 2 horizontal, and one vertical here gives us 1.8 horizontal. Okay, if I name this distance, which is the vertical distance, if I name it H, so this unknown distance, it is H. Therefore, what do we have here on the left? Because of this one vertical gives us 2 horizontal, so 1H vertical gives me 2H horizontal. You see this one, 2H horizontal. Okay, and one also from right side, 1H vertical gives me 1.8H horizontal. If I take summation of this 2H plus 1.88H, it should give me the 1.52. So in this way I can get the vertical distance. If I knew H, then plus 0.85, I can directly know the Yn of the channel, Yn. Okay, you would ask me why we didn't use the Manning equation, because this charge is unknown, so we can't use this charge is known, this charge is known, there should be something unknown maybe. No, actually everything is given. We can use the Manning equation as well, because everything is there. N is unknown. Yes, it is one of the questions here, to find N, which is roughness. Okay, so this would be our problem. You see, N wasn't given. There should be N, which is the roughness of this channel. Okay then. So what I would continue to say, which is get the area, for example, area and perimeter. Therefore, area it's easy. We can take, for example, rectangle 0.85 by 1.52, this one, plus half times the base, which is 0.72. How he found the base is 0.72? We found h to be 0.4. Therefore, if we need this base, 0.4 times 2, this would make 0.8. This is the answer here, this base. And the other base is 0.72. So we are just multiplying 1.8 times h, which is the h distance that we found. Okay? So, if we step by step check here also, this should be checked here before we continue. Okay? So we found the area, for example, area of this triangle and that triangle. I will be not that much revising the geometry because it is geometry. It's easy. Okay, you just make it simple, divide it into smaller, what we call it, smaller parts. Therefore, you can calculate and you can solve it at least. Okay, what about the yes, we got the area, for example. For perimeter, we would say it is 0.85 times 2, which that's what I did, 0.85 plus 0.85, which means this side, let me take another, let's make it like this. So this one and this one, plus then later these two, which will be by Pythagorean theorem to get their length of these diagonal parts. Okay? So we got the perimeter, therefore here it is asking about n, then I would say n will be, I don't know if n is given, it seems it's not, therefore, we got n, for example, here, I don't know, what is this extra, it says, maybe n was given, I'm not sure, anyway, so we found n, for example, 0.014, or just as a check for yn. If you go and check, for example, yn, and maybe it is given 0.014, I'm not sure. So if it is given, therefore this solution will be an extra part to get yn, because it seems here I wrote it for yn as an unknown. Okay? Anyway. But if it was yn, no, it's not like that. Anyway. Forget about this extra part. So it continues with, now we find hydraulic radius. We know hydraulic radius is area over perimeter, therefore I get area over perimeter and we got the answer. Then what is next? Hydraulic depth. What is hydraulic depth? A over T. Don't say it is for RH, it's totally wrong, okay? For RH is totally wrong. Therefore hydraulic depth is A over T. We get the answer 1.05. Then velocity, how much is the velocity? What is the velocity? It is Q over area. If we directly divide Q over area, we can get the answer. Then energy, it says, what is the energy? We know it is Yn, this is Yn plus Q squared over 19.62 area squared. We have the area, we have a Q, everything is given, therefore, or just found, for example, is founded. Therefore, we can get the answers directly. Okay, then, what is next? Finding the shear. Finding the shear stress. Shear stress formula is given by what we call it gamma, which is the unit weight, hydraulic radius times bed slope. So I should substitute gamma. It was given to us gamma as 9,798 Newton per meter cubed times RH, which is hydraulic radius. We found this one before, times bed slope, which was given. Therefore, this is the answer. So it was done. Continuing with fluid number, we are done with this one. Now with fluid number and then flow regime. So fluid number will be, if it is asking about fluid, don't forget, we will take the square root, therefore we should take it to both sides. So it will be root of Q squared T over GA cubed. Therefore Q squared 2.8 squared times T, which is 1.52 over 9.81 A cubed. This is it. Which is, we got it as less than 1, a value that is less than 1. Therefore, it is subcritical flow. T, we found T, it was here in the beginning of the question. It was 1.52. just to remember from where we got the answers. 2.8 was the Q, and area, we got the area before. So that's it. Okay, so that was the whole question, and let's continue. Here we have another unit which says classification of channels, for example. We have channels can be classified based on two things. First is based on Manning roughness, uniformity. We have, if the whole channel consists of one roughness value, one roughness which is N, therefore we call it's a simple channel. But if it is composite, it means we have multiple N. For example, composite like this one, we have N1, N2, N3. For example, each member, it has different roughness value. If all it has same roughness, therefore it will be simple like this one. So another classification is based on cross-sectional shape. So cross-section, if the cross-section is single, like this one is single, like this one is single, or there is a combined or compound. Okay, combined or compound, it's like this one, you see. So we say it has 2 points that is able to create two maximum discharge values. So we call that one, for example, Q1, and this one we will call it Q2. So the total Q of the channel will be the summation of both, 1 plus 2. So here you can see the 4 different combinations we have, which is, for example, here single and simple. Single and simple means single so that it is the cross section is single, one only, and simple means it has only one N that is same. Now case 2, single and composite. So single, again single for what? Single for N. Single for the cross-section shape, and composite in terms of N. It means each member has different N value. Okay, so 3, which is compound and simple. So it is compound that is consists of many parts. That, for example, here I would say there will be like this, the contour lines of water. Here it would be able to, for example, make another one here, and there another one like this. Anyway, okay, compound and composite, which is different N values for each member, and also the cross section is not simple. So I should divide it like this. By the way, these divisions, you will try to take, for example, any breaking point that is suddenly, for example, here this is a breaking point, that is another breaking point. So specifying these breaking points will give you a glimpse on how to divide the section, because basically we will divide the section into subsections, simple sections, and try to get the discharge of each one by Manning equation. Okay, each one by Manning equation by using vertical interface excluded. What does it mean, vertical interface excluded? It means if here this one, the dashed line, which is we divided, we don't take it into perimeter calculation, and we don't take the length of it into the calculation. We take it only, and it's just a border. We don't take it in the perimeter at all. Okay, that is, keep it in mind. We take only, for example, we take only the, what we call it, the border, which is weighted perimeter only, weighted perimeter of the channel. Okay, that's the important thing. Let's take this simple question, and not about the cross section, just as an example. It says the given channel is called compound channel. It is usually full during flood conditions. The flood channels are 10 meters wide and have sides slopes of 1 to 3, which means 1 vertical gives me 3 horizontal, with Manning roughness coefficient N equals 0.035 for all over the flood channel cross sections. And the main channels at the middle has side slopes of 1 to 2. Yes, that is the one here in the middle, here, this one and this one, 1 to 2, with Manning roughness coefficient N equals to 0.015. The longitudinal slope is 0.001. Find the discharge Q for a flood level of 4 meters. Within this channel, all the values are in meters. Okay, so how I can start? This one, it seems it has only one n value, therefore it is simple. This one is simple in terms of n, because it's only n. And what? And simple and what? And compound. So anyway, simple and compound. Okay, so how we can start? I should divide using the vertical interface excluded. Therefore, I should divide the channel into 3 channels. Here we have divided, here we have divided at the breaking points. So this question, for example, it is clear that I should divide in this way. So what I did is, depth was given here as 4 meters. Here it was given as 4 meters. Therefore, how I can solve it? How we can get the other depth, for example, this depth. How I can get it? This one here. What I can do is that 10 minus, or even here in the middle, how we can get it? 2.5. Forget about that one. Anyway, I will start like this. So how much is this y? If I call it y, I want to know this height. Here it is shown that this distance is known, because distance from here, from this line, 14.5 up to the end, but it is 10 up to this point. So how much is here? It is 4.5, isn't it? 4.5. So, and what is this ratio? It says the vertical, it is 1, 2 to 3. Therefore, one vertical, which is 1y, should give me, for the base, 3y, 3 times y. One vertical should give me 3 horizontal, 3y. Horizontal, this is horizontal. Okay, that one is vertical. So the ratio vertical to horizontal, it is 1 to 3. Okay, because it was given here, 1 to 3. Okay, so 3y horizontal. How much is the horizontal distance? We know it, it is 4.5. It is 4.5. Therefore, how much is y? From that equation, I can know it y vertically, it is 1.5 meters. So we can know that this distance is 1.5. So if it is 1.5 and in the middle we have 4 meters, therefore how much is left here? 1.5 minus 4, it is 2.5. Okay? So it's easy. You can do it the opposite, in the other way. How you can do it the opposite, I will show you. We can do it also here. If here I close this triangle, for example, how much is the base of this triangle? It is easily can be known, because here we have 15 meters, and here 5, and here also we have, it is equal, because this one also ratio is 1 to 2. Therefore, it should be 5, 5 to make all 15. Also from the figure it is clear. Therefore, 5 horizontal, which means how much is the vertical? If we call it y, so 1y should give me 2y horizontally. So 2y equals to 5, which means y is how much? 2.5. Okay. So in either ways it will be. Then you can find this one is, because this is 4, so I can know this one 1.5. If this we know it 2.5. Okay, so we are done with that. Later on, after this, I would call this one the main one here. We have called it, for example, this channel. We have said this is 1. So here, what the calculation of that one? Therefore, it is 1.5 times 15 plus 2.5 times 5 multiplied, which is, let us check it, for example, quickly. 1.5 times 15 meters, which is this one, 1.5 times 15. So we are done with the triangle, the whole triangle, rectangle, sorry, with the whole rectangle here. Okay, next We have another rectangle down, which is 2.5 times 5. This 2.5. 2.5 times 5. Okay? Plus 2 triangles. I should say either 2 triangles, or I can take summation of their base, which is half times the base, which is 5 plus 5 makes 10, times the height, which is 2.5. Okay, we got the area. Then, just to clean it a bit, what is next? Next is to get to perimeter. What is the perimeter of this channel? The one here too. I should only take this member and this member and that member. Okay? So I should say 5 plus this, which is 2.5 and 5 under square root 5 squared and 2.5, and I should multiply by 2 because I have one on the right, one on the left. So it will be, this is the perimeter of that channel. We got it 16.18. What is next? Q1. Now how to find the Q1? We will substitute. This is the area. This is n. N was given for the whole channel. It's saying root of slope over perimeter power 2 over 3. We got the answer. Okay. Next is finding Q2 and Q3. It will be the same. So what is the area of that one? 1.5 times 10. Look, if you divide everything and if you draw everything in details, it will be so easy. So 1.5 times 10 plus half times 4.5 times 1.5 again for the height of the triangle. Okay, like that. So perimeter will be only this square root of 1.5 squared plus 4.5 squared plus 10. That is the area. Okay, we got both answers. Substitute it to the Manning equation. Area power 5 over 3, this is n. N is 0.035. Here it says we have, it seems, yes, the other one 0.035 flood channel, while the main channel it has 0.015. Therefore these we have them 0.0 how much 35. Okay, be careful. The n. Okay, so and lastly we take the summation Q total, which is the summation of all of them. So that was the the only question which was asked for us. Okay, continuing with this one, here it says for the given compound and composite channel cross sections, if the depth of the flow is 2.8, which is yn, the channel's bottom slope is given. Determine the discharge by using vertical interface excluded, which is this one approach. Then also flow regime of the cross section, then also critical flow depth of this cross section. Note that VIE approach is the closest result, which is the best result, for example. Okay, how I can divide this one? We have also here multiple n. I will show you how to deal with it. Therefore, for dividing the one, we said here we have the breaking points. This one, for example, and this one. Therefore, I should what? I should break the channel from here. I should break the channel from here as well, vertically. Vertical interface, because it says, okay. So, I have shape 1, shape 2, and we have shape 3. Okay. For each shape, I should get area and perimeter. And also here another unknown, which is n equivalent. This is the first time. If we have a compound or composite channels, we divide it into sub-channels and calculate. But now it is not simple. What do we mean it's not simple? It means it is what? Composite, isn't it? Yes, compound or combined. Now that's composite. Yes. Now, composite, what does it mean composite? It means it has multiple n values. If we have multiple n values, therefore that should be checked and calculated differently. How? By n equivalent. So because we need only one value for each sub channel, which is 1 and 2 and 3, we need only one answer of n. Therefore, that's why we need an n equivalent, and that n equivalent will be using what? Einstein method, which was here discussed. This one, Einstein-Banks equation. This is Einstein, the son, not the other, the main Einstein. That is the one who worked on physics. This one who worked on the hydraulic. Okay. So it says n equivalent is summation of perimeter times n squared over summation perimeters under the square root. Totally all under the square root. Therefore, what does it mean this? It means if we have a channel like this, like that, anyhow, so each, if it has an n1, n2, n3, n4, and you want to get an equivalent of this n, only one answer for all these, it says take the perimeter, which means the length. So I should take this length multiplied by L1 multiplied by N1 squared. L1 N1 squared, or we can call it P1, by the way, it's okay also. Plus then P2, for example, this length, which is P2 perimeter 2 N2 squared plus like that, then all divided by P1 plus P2 plus P3, like this, and it goes, okay, like that, and get the answer. For what? For n equivalent, we call it. Okay, that represents the whole n's, all under the square root. This will be all under the square root. Okay, so let's see how we did it here. We divided the channel, as you can see here. We divided the channel here. We have divided the channel, and here also we have divided the channel, as I showed you before. So first one here, it will be, we have the vertical ratio. First, what I would like to clarify is I always try to finalize these distances, okay, which are the diagonal distances here, this one, like this. Why I try to finalize it? Because it depends on this ratio. So mainly they gave us this one to 2.8 it says. Let me see the given. Yes, but he gave us the rest. Yes, these are given, all given. Therefore we can directly get this one, because this one it says 1 to 1.3, so we can say here it is 1.3 times 0.7, isn't it? Here I can say how much it is. It is this distance vertically, vertically how much is it? 2.8 minus 0.7, 2.1. 2.1 times 1.7. So I can put 1.7 times 2.1. Okay? And the other one from that side, 1.4. 1.4 times, how much? How much is this? 2.8 minus 1.9, how much is the rest? 0.9 it seems. Yeah, 0.9. So times 0.9. Okay, easily we can get the answers like that. After that we continue solving. How we continue solving? We should get n equivalent for each channel, because we said this one represents one channel. So what is the n equivalent for this one? It will be length of this one, length of this member, which is square root of 0.91 squared plus 0.7 squared multiplied by 0.016. Here I'm checking, I'm reading from there, you should check here. 0.016 squared plus 4.1, which is this length, multiplied by 0.013 squared. Now under all over this one, we take the perimeters, this one plus the perimeter, this one. Okay, all to the power half. So don't forget this half. If you forget it, if you are not sure to, maybe you would forget this one, try to put a square root, for example. This answer is wrong because I forgot to put the squares also to the ends. Okay, n should be squared. Anyway, it won't make a big difference with this value. it will be so close, maybe 136 or 138. Okay, so the rest, after that we say what is the perimeter of this channel, of this part. It will be also this answer. This was actually perimeter 1, the channel perimeter. Okay, this is it. We didn't write it, but it is the perimeter. Area, we should calculate the area. I would say it is how we can calculate it. Yes, it will be 4.1, which is this one, multiplied by 0.7. So it's like this. And the triangle, which is half times the base, 0.91 times the height, 0.7. Okay, like that. Okay, so for Q, then after we found area and perimeter, therefore I would directly substitute into the Manning equation, which is area power 5 over 3 divided by n equivalent. Here we needed the n equivalent, you see, times root of slope over perimeter power 2 over 3. We got the Q. Then for the other part, we need to get also the n equivalent again. What is the n equivalent here? I should take length of this part. How much it will be? Length of this part, it will be square root of 3.57. You see, if you prepare everything, it will be easy. 3.57 squared plus 2.1 squared, all under the square root, multiplied by 0.016 squared. You see, 2.1 plus 3.57 squared to 0.016 squared. Plus the horizontal one now here, which is 3.4 as a length, and 0.027 squared, plus the diagonal one here. So what is the diagonal? It is the vertically 0.9, so 0.9 squared plus horizontally it is 1.26. So 1.26 squared plus 0.9 squared times the n, which was 0.019. Under the divided, all divided by, directly you can select these. These are the perimeters, so you should take these and repeat them in the denominator. Okay, you should put them sum up. Okay, so all under square root, and you can get the equivalent n. Okay, yes. So after that, what we say, Q2. Again, we substitute the result of area, result of perimeter, and the result of n equivalent. S is same. We got the answer. It is done. The last one, it is so easy. It's just at rectangle 1.9 times 5.1. That is the area. Perimeter will be 5.1 plus this one. Here, this one. Let me take another color. Which means this one, this side, and this side. Yes. And for n equivalent, we need this one, 5.1 times 0.021 squared plus 1.9, which is this member, times 0.015 squared. Okay. Over, again, repeating this one and this one, and then equals to, we get the answer. Therefore, and then we substitute also for Q3, then the summation of the 3 Q's would give me the last Q inside the channel. Okay, that's it. Now, coming to part 2, what it was saying, part 2, find the flow regime. Flow regime. How we can get the flow regime? By fruit number. If it was less than 1, it would be subcritical. If it was greater than 1, it would be supercritical. So what we check here, we say for flow regime, it says fruit, we need fruit, but the fruit, this one, which is square root of q squared t over ga cubed. What we can take in fruit, actually, be careful, you should deal with the whole section. Okay, if we will deal with the whole section, therefore we need t for the fruit number. Therefore, I should take the summation of all these. That's why I've put the blue, 0.91 plus 4.1 plus 3.57 plus 3.4 plus 1.26 plus 5.1, and that's it. That will make t, this t. In addition to taking the areas, how I can get the area? Because here it says area cubed. So we solved T problem, and Q we have it. We would use this answer. We need area, and area we can easily take this A3 plus that A2 plus A1. This will make the area of section. So no need to go again and calculate and check. It's just everything you did before, you just choose from there. 100 square root, and that is Q total, and we have put here T, and then the answer was 0.44. 0.44 is less than 1, therefore we have subcritical flow. Okay then. Now, coming to the last part, which is the Y critical. Here we have an important concept for finding Y critical. For finding Y critical of such a channels, we have to go step by step. What does it mean step by step? You should be careful to the breaking points. Here we have a breaking point, and here we have a breaking point. So first we check the lower one, which is this one. How much is the height of this one from the deepest point of the channel? It is 0.9. You would say it is 0.9. From the deepest point of the channel up to there, it is 0.9. Okay? So first we have to assume Y critical will be less than 0.9. Yesterday we saw how to find how to solve and find the Y critical by equating fluid into 1 and write the area in terms of Y and T also in terms of Y if possible. Okay? Assuming Y is unknown. Depth of water inside the channel as unknown. Okay. If we assume it in this way, therefore, what will happen? If you assume it unknown, you should write the area as in terms of Y. But here, because the shape is like that, we can't assume this whole is Y. How we can make sure that the Y critical is that much high in depth? What do I mean by high in depth? Which is like it's greater than 2.1. How we can make sure it's greater than 2.1? No one knows. That's why we need to firstly assume it less than 0.9. And by assuming that the Y critical is less than 0.9, we mean by that the area formulation, the area equation, and T will be different. Different if the whole section is filled. Let me explain it to you now. Look here. If the area with the Y critical is less than 0.9, it means it will make up this much shape, which is like only a trapezoidal shape of water. Okay, if it was greater than this breaking point and less than the other one, which means the other case. Yani, let me write the first one. The first one, Y critical is less than 0.9. Okay, this is a case. Then the other one, Y critical is less than 2.1. Less than 2.1 makes another shape. Which is this one, you see? Which would make this complex shape. Kind of a complex, yeah. So it would fill here, this side. Okay? The last option, the very last option is just to say it's greater than 2.1, therefore it would fill up to that level. Okay? So area will be different. So in each step we will have a different formulation or different equations for area and what? For area and T. Okay? Why we are always mentioning T? Because if you have diagonal members, that depends on depth, therefore they will be written in terms of depth. Therefore our T value will be dependent on that vertical depth. Okay, yes, that's the thing. Okay, then you understand the concept. We have to do it this way because if we do it up to the max, maybe it would give us a value, but the real value is not that one. Maybe it is less than 0.9. The real Y critical value, I mean. Because the upper one, it has no criteria to be checked. You will get an answer and you don't know if it is correct or not. But if it was, we are assuming less than 0.9 and we got less, then that's true. That is the y critical of our channel. Like that. Okay then. No need to make the things more complex. Let's just continue right now. Okay. So what we did here in the calculation, I said assume y critical is less than 0.9, therefore y critical for food equals to 1 will be. Here we assumed the first one, which is our first assumption. I don't know what is the other one. We made the first assumption, which is if we assume this one y critical, therefore here from left we will have 1.4 y critical and here 1.7 y critical. You see, it will be 1.7 y critical. Therefore, what is the area? Area of this shape will be y critical. Let me take a thinner pen. The area will be 3.4 times y critical plus half times 1.7 the base, 1.7 y critical times the height, which is y critical. So sometimes I'm writing it like this, half times 1.7 y critical squared. Why I'm directly putting squared? Because the height of the triangle will be y critical itself. Okay, so try to write it this way because it will be easier. Yes. Okay, let us zoom out and check what we wrote. Here I think we wrote it directly as an area. Half times 1.7 y critical times y critical. We can make a square directly, plus the rectangle in the middle, which is 3.4 y critical, and here the other triangle, which is 1.4, because here 1.4. Here I did it, for example, half times 1.4 y critical squared. Okay, forget about this 5.1, it is not with us. We are dealing only with this small part up to here. Our first assumption, that is, we are below than the breaking point, which was here. Okay, water should stay below, which is here. Okay, like that. We found the y critical, it is 2.22. How much after using the solver? By the way, for t you take this summation, this up to here, I mean, okay, up to here, which is the from top, I mean, from here this one is t. Okay then, and okay. And therefore, what we can say, this is t. Yes, that is t. So we got the answer 2.22. Is it correct with the assumption? We assume that y critical will be less than 0.9, less than the first breaking point, because in order we should go. It is not. Since it's not, what we can say, it's greater. It is, we can say not less than 0.9. Assumption is wrong. What does it mean assumption is wrong? Go and assume that we are below the other breaking point, which is 2.1. Okay, if we are below 2.1, it means if we erase these, it means we are now, keep that one. We are now here. See, we fill the water. Don't fill the water, by the way, don't fill the water like that after the breaking point and solve and say it is 2.1. Like this you are saying y critical is 2.1. Don't do such a mistake, okay? Just fill the water up to a level that is below than this 2.1 and upper than 0.9, so that you don't confuse. So what we do here is we would say the whole vertical distance, this one is y critical. Okay, so y critical, that makes this triangle on the left, triangle height. Therefore, again, this one will be 1.7 y critical. Okay, that's perfect. What we say about the other one? Here now we don't say it is 1.4 y critical about this triangle. Look with me. This triangle we have it complete depth, which is 0.9. So I should say it is 1.4 times 0.9. Because we passed that point, now we know it. But how much is above 0.9? This one, the unknown. How I should write it? This should be written as y critical, which is from the bottom, because this is from the bottom up to the top. Up to the top, it is y critical. Okay, so this would be y critical minus 0.9. Okay, minus the distance that is just below. That is just below. Right? Like that. So, what we can say about that then? Taking the areas. Taking area of this triangle, how much it will be? Half times, let me write it here, half times 1.7 y critical squared. Y critical squared. Okay, plus. What is the next? Rectangle in the middle, 3.4. Sorry. 3.4 y critical, not squared, there is no need for the squared, sorry. Y critical. Plus, what is the next one? Triangle there, which is half multiplied by 1.4 times 0.9, 1.4 times 0.9 times 0.9. Like this. Okay? Plus the other one, which is what do we have? We took this rectangle, the whole rectangle, this one we took it. The other one we have this rectangle. Y critical minus 0.9, which is the height of it, is y critical. Y critical minus 0.9 multiplied by 5.1 plus that distance. This is the whole distance. So multiplied by 5.1 plus 1.4 multiplied by 0.9. Okay, like this. This is the whole area. Okay, this is the whole area. And also summation of this one, these distances from here up there, it is t. This makes t. And it is 1.7 y critical plus 3.4 plus this one plus 5.1. Okay, so that's it. Here. This one, yes, by mistake, this one was 5.1. It should be 5.1 plus 1.96. Anyway, then we checked it is greater than 2.1. Therefore, unfortunately, in this question, again we should repeat it to fill the whole section with y critical, and then solve it, which is here. So what we say about this one, I should therefore complete this one up to the breaking point. Therefore we know the value here because this was 2.1, and here also I complete this one, which was 1.26 because it's 0.9. And how much is this height? Y critical minus 0.9. What is that height? Y critical minus 2.1 because we passed the breaking point, isn't it? Like this. And after that, what we say about the rest? What we continue? Yes, actually we take the summation. By the way, for these, because here we have it, it was 1.3, 1 to 1.3, so it should be written like this. One vertical, which is this one, it should give us this. So taking area of this triangle, by the way, let me just help you in this. It will be half multiplied by 1.3, half times 1.3 times y critical minus 2.1 squared. Make it squared, it will be easier. Okay, directly like that. That one is the area. Okay, and solving for y critical will give us this much. So practice these. Solving for y critical for such questions, it is a bit harder than the normal ones. But at the end, it's just about equations. Writing the area correctly gives you the correct answer directly. Okay then. So, coming now to another concept, which is it says classification of gradually varied flow profiles. What this one discusses is that, as we said, we have a subcritical and supercritical flows. Therefore, the change between, let's say, between subcritical, for example, maybe I would have a slope that is subcritical and then another slope that is also subcritical, but maybe it will be more mild or less mild, let's say. What is about mild? Let's mention that as well. Mild represents also subcritical, so it's same meaning. Steep means supercritical, so it's like that, same. But it is related to slope, okay? So steep, it means like it is, so what we call it, like this, such a steep slope, for example. It's like this. Mild, it means no, it is like, as you know from the word mild, that is like not that much slope or not that much steep, like this. Okay, so these changes will play a role, and then we can there will be something called gradually varied flow in such cases, which is changing from one channel slope, which is S1, to another channel slope S2. These changes will cause something called a gradually varied flow. Okay, so in water, that is the thing we will study. Firstly, we should remember that we have a normal water profile in the longitudinal view of the water, which is this one. So this represents yn, this represents yn, while the other one, the red one, represents the critical depth. So if yn now here is above the critical, which means this sketch is for a subcritical flow, isn't it? Subcritical flow, because we draw the yn greater than critical. If it was like this, drawing like this, the yn, it means it is what? It is a steep, which is a supercritical flow. Okay, so what we study is here is that here just this one practice question about the changes. I will show it to you. Wait, there are many questions actually, many questions. Anyway, I will leave this question for you. We don't solve the whole questions because we won't have time to solve all of them. But for this one mainly, the questions are, let us check down. Also, these questions are, just take them for practice. We can discuss them if you have any questions in them. For example, this one also, it's easy. Let's just step into these changes. Yes, this one. So what is it mainly? Mainly we say if we change from mild to milder slope, from mild to milder, and here is the breaking point in the slope. Okay, so this will be the breaking point. So what is basically what we say is that water will try to fix this change. What does it mean mild to milder, by the way? Both of them subcritical flows, both of them subcritical, but because we are saying milder, it means the water depth here, it was something above critical, but after that it was more above the critical, which means y2 is now greater than y1. So the water should go into a deeper depth, which is into a higher depth of water. Therefore, we would use what? We would use M1. How we know that it is M1 curve? Because firstly, and why we draw it before the breaking point? Because here it says for this kind of changes, for this kind of changes, it tries to fix itself for mild sections. I mean, it fixes itself before the breaking point. Before the breaking point, which is, we call this one in layer 1, for example. We try to number them. Then between yn and y critical, it is layer 2, and between y critical and the bed slope, it is layer 3. So if you try to connect, this one is coming like this, yn1, and you leave a space, you need to connect to a higher point. So you would use a curve like this, isn't it? So what is number of this curve? I put here a line, you see the green line here, that this one I already draw. This one as if the flow is continuing there, as if the flow is continuing. So the curve is where? Is above this line, which means in layer 1. So I would call it M1. If some people, some students, they are memorizing these, it's the same because this won't change. If it is the case mild to milder, this won't change, but I want you to understand how we got them as well. So the second one is mild slope to less mild. Less mild means lower depth, but still it is subcritical, both of them subcritical, okay? But less mild means the depth got reduced, okay, based on any factor. Like for example, the factor will be the slope, mainly is the slope actually, okay, S1 and S2. Okay, so again we say that it will fix itself before the breaking point. Therefore you should draw a line here and say this is the breaking point, and then you try to, because the flow direction is always like this, by the way, we put the flow direction is always like that. Okay, so I draw a line here, say this is the line of the water, and then put the, what we call it, yes, that is the line already, you can see it. Therefore put the numbers. Then what is the curve? We see the curve is now not going like this, it's not in layer 1. Check the line, where is it? It is in here, in the layer 2, isn't it? In the layer 2. Always remember the breaking point, after that you judge it. So it's M2. So we call this curve is M2 curve. These are the gradually varied flow. This one we call it dispersion. It is gradually varied flow. Dispersion is gradually varied flow. Anyway, and then also coming to steep cases, which we have supercritical flows. If we have a steep and then going to steeper. Steep normally it is related to less in depth, like that, less in depth. Therefore if we say steeper, it means lower depth also, lower than the previous one. So steep to steeper means the depth got reduced. In steep cases and supercritical cases, the main thing is that the water won't get the chance to fix this change before the breaking point. It will fix it after the breaking point. Therefore it will be as a shock to the water, okay, after the breaking point. So after the breaking point, I put here the breaking point border, and then try to leave a space. This is the new depth, that is the above. So you try to connect it. If you connect them, it will be like that, like this curve. Then put the numbers. We should number the right side. In supercritical case, you should number the right side. So 1, 2, 3. So we are having what? We are in layer 2. So we are in layer 2, it will be S2. Okay? Like that. Then the last one, which is less steep, steep to less steep, which is a higher depth, but both of them less than the y critical, same as the one here. So both of them less than y critical. So again, it will be S3 because we are in less going to up, and we should number the right side. No, don't forget to break the point like that and number first, and then between y critical and yn is second, and then after yn and the bed is 3, and like that. So it will be S3. So these cases will be always the same, nothing will change, but just try to understand what is the main concept. Here we have a special case. This one we call it a hydraulic drop. What does it mean, a hydraulic drop? Actually it says if it is changing from mild to steep, which is from subcritical into supercritical flow, Here we have a special thing that is M2 up to the breaking point, and then from the breaking point it continues S2. So we call it M2S2, M2S2 curve. Okay, like this. This is a special case from mild to steep. If it was the opposite, if we have the opposite, steep to mild, we have this case which is a hydraulic jump. We call it a hydraulic jump. Okay, that either will be after, in mild portion, in mild region it will be, because this is S to M, so either in M side or it would be, because here also S to M, so maybe it will be in the S side, in the steep side, like that. So here we have a practice. It says a rectangular channel of bottom 7.55 carries a leverage discharge of like that, and we have bed slope 1 and N1, then bed slope 2 and N2, which are given here actually, these, and it says classify the slopes, draw longitudinal profile, and name the occurrence of a non-uniform portion. So what we need basically is to only get the y, to get y1 and get y2, because we have the discharge from Manning equation, and then get also y critical for such a profile with a B is 7.55. By the way, all these questions always will be having a rectangular cross section. Any questions that is asking about drawing the profiles, which is like M2, M1 and S and like that, these questions all will have a rectangular cross sections. Okay, we won't face any other shapes. So here what I did is, first I got the y critical from the fruit, so we got y critical. Then for yn1 and yn2 we solved it using the Manning equation. You should only change s and n, and then maybe in other questions you should change something else, but this one is like that. After that you compare it with y critical. Both of them, they were less than y critical, but if we forget about this one, what is written here, both of them, they were less than y critical, but the depth is increasing. So I should say it's not steep to steeper, it should be steep to less steep, because the new depth y2 got increased. It is greater than the previous one, but both of them, they are steep, right? So steep to less steep, and if we draw it like the case we studied above, it should fix itself after the breaking point. You should know how to draw this one and put the numbers and like that, so it's S3 curve and like that. Here we have another question, different numbers, different things, again same concept. You should get y critical, yn1, yn2, and we got the answer mild to milder, for example. Okay, so these questions are somehow, this one we have 3. Again, you should deal with each one separately. Get the yns, get the y critical, then yn1, yn2, yn3, and like that, and so on. They asked here maybe for S critical also, slope critical. By the way, for while finding slope critical, you need to use y critical into the what we call it, into the Manning equation. I don't know if they found it. No, they didn't. Anyway, we'll discuss it later. It's fine. Like that. About drawing energy curves, I think this lecture it became too much for drawing also the energy curves. We should discuss this one later, I think. Yes, this one later, hopefully. This is chapter 9, but yeah, this one we will discuss it later. Energies. Okay then. Energy, if you can prepare for the coming session, it will be about the energy and how we will deal with it. Basically, the energy curve will be something like this. This will be the minimum energy, which is E minimum. At Y critical, this is at Y critical, and that is E minimum. And at the E of the channel, we will have both answers, Y and another Y, and like that. Okay. We will discuss these later on. And also for finding length and like this, it will be easy, hopefully. Try to practice different questions with different ideas, therefore you would be ready like these questions, okay? Forget about drawing the energy curves, we will study these, but at least you should get ideas how to deal with these, dividing the channels and like that, okay? That's it for our session. See you then on the coming session, hopefully.